Welcome, my fellow software enthusiasts. Today we're going to talk about Docker, what it is, and when to use it. And if you enjoy the video, please hit like and subscribe. It really helps the channel. Thank you. I think it's best to explain Docker with a problem. And this is a problem I just faced last week. So, you're developing some software. You finished making some changes, and now it's ready to test. So you install it on the test machine and you begin testing. But wait, there's a problem. Something's not working. You go back to your computer and you try the exact same thing and it works. So we have the case of it works on my machine. Have you heard that before? Probably. So what do? Well, you can't just use your machine for everything. You can't have everyone use your machine and test and everything. So you have to figure out what the difference is between your machine and the test machine. So you check the OS, you check the libraries that are installed, all the packages, you check the environment variables, you check the test data, and so on. This can take a very long time, and certainly something you don't enjoy doing. You rather get back to developing, right? But without proper dependency and configuration management, this can happen again and again. We don't want this. So what are our options? Well, you might start thinking, wouldn't it be great if every single computer had the same software and versions? Okay, let's go down that road. You start by looking at provisioning software, something like Ansible or Chef. You start writing the script to install all the libraries you need and all the versions you need for this application, this release. That's great. You've set up machines that have identical software. Now, you want to make an update to a library. Maybe you want to go from Python 2 to Python 3, or you want to upgrade the OS. What do? Do you update the script and then install everything all over again on the machines? But what do you do if you have to support multiple releases that have different versions? Okay, so this isn't going to work. Plan B. I like the idea of the automation. That was great. Let's keep that. So the next step is maybe virtual machines. I mean, you can run multiple virtual machines on a computer, so you could have two versions on the same machine. All right. This sounds promising. So you begin setting up the virtual machine. It asks how much disk space, how much memory you want. And you start thinking, well, how much do I really want? And you probably will overestimate because you don't want to redo this again. So what do you end up with? You end up with a VM with more memory and more disk space that it's even needed. You're not actually using. So how many VMs can you run on your machine? Probably not that many. So you face a scaling problem. There's only so many VMs you can run on one machine. Okay, virtual machines were pretty close, but they had a little bit too much overhead. And the whole idea of virtualizing the hardware isn't really necessary for our problem. We only care about the software. So there's something that would only virtualize the software. That's where Docker containers come in. A container is a way to package up your application, all its dependencies, all the configuration, environment variables, everything you need. Remember the things that we checked between the two machines earlier? We checked the OS, we checked the libraries, we checked the environment variables. All of this can go inside of a container. So this is exactly what we're looking for. In short, containers are essentially packaged environments. So let's go back to our scenario. We had our developer machine and we had our test machine. So how does Docker fit? What we would do is create a Docker container that packages our software, the application, the libraries, everything we need. And we would use that on the developer machine and the test machine. So instead of installing our application on two separate machines, we install it once inside the Docker container. And then we run the same version and everything on 2 machines, or more than 2 machines, as many machines as you like. So that way, there's no differences between the 2 machines. You can run the Docker container reliably from machine to machine. Thus, with Docker, hopefully we never have to hear the phrase, "It works on my machine," ever again. Docker containers offer much more than just packaging, though. You can create networks, you can set up ports, you can change the host name, you can set resource limitations or restrictions on things like memory and CPU cores. There are many ways to use Docker. I've been using Docker for about 5 years now, and I've used it to support a legacy application running on a 10-year-old operating system. I've used it to set up a web service with my REST API for an application that I'm testing. I've used it to do CI builds on build machines so that the machines don't have all the dependencies for my project. Thus, the machines can be used for multiple projects with different dependencies. And I've used it just to keep my laptop or computer from having all this bloated software installed for my projects. I don't have to install it. I just keep it in Docker, and then once I'm done with the project, get rid of it. It's gone. I don't have to uninstall anything. I'm sure once you start using Docker, you'll find many creative ways to use it. And a good place to start is by going to Docker Hub. There's several popular operating systems and projects where you can just give them a try. It's pretty easy to set up. I hope you enjoyed the video. If you have, please hit the like button and consider subscribing if you haven't already. Thank you. Until next time, happy Dockering.